Here we have the integral of arcsine of x, and you may have noticed that I've kind of given you a hint on how to find this integral. It's a integration by parts, but the real challenge is selecting the u and the dv. In this case, we actually want u to be arcsine of x because we can find its derivative. Our dv is just going to be equal to dx. So, taking the derivative of u and then multiplying the differential dx over, we get du is equal to dx divided by the square root of 1 minus x squared. Integrating v, we just get v is equal to x. We can now plug this into our formula for integration by parts, and we get arcsine of x times by x, which we're going to just put out front, minus the integral of v, which is just x dx, divided by the square root of 1 minus x squared. Now we're going to use u substitution to evaluate this integral. So we get u is equal to 1 minus x squared. The differential du must be equal to negative 2x dx. Solving for the differential dx, we get dx is equal to du divided by negative 2x. Now we have to sub this into our integral. So we get the integral of x divided by the square root of u times by du divided by negative 2x. The x's will cancel, and we can pull out the negative 1/2 out front. So this becomes negative 1/2 the integral of u to the negative 1/2 power du. Integrating this now, we get negative 1/2 u to the power of 1/2 multiplied by the reciprocal is 2. The 2 and the negative and the 1/2 will cancel. So we are now left with just negative x, 1 minus x squared to the power of 1/2. But remember, we are subtracting this. So this is arcsine of x minus negative 1 minus x squared to the power of 1/2. So now we just have to distribute the negative, and we get x arcsine of x plus 1 minus x squared to the power of 1/2 plus c. And this right here is our solution for the integral. I hope you all found this video informative.